In Unit 2, we're going to start by talking about characteristics of functions. We're going to first compare a relation versus a function. A relation is simply a set of ordered pairs. There's no rules involved. It's just if one thing is paired with another. So if you look at both of these examples, they're both relations. There's no set rules involved. When we talk about a function is a relation, but there are certain rules applied to it. Here, a relation that assigns a single value in the range to each value in the domain is a function. So basically, and you've probably heard this before, is x does not repeat. So here, when you look at these relations again, the first one is a function because your x does not repeat, or it goes to each value in the domain. So it is a function. The next one, though, notice that we've got 3 odds that go to 3 different values of the range, and we've also got 2 evens that go to different values. That breaks the rule that x does not repeat. So this one is not a function. Now, do be careful. They try to trick you sometimes. If I added another 2, 4 in here, that would still be a function because these are the same coordinates. So don't just focus on the x that repeats. If you saw this and saw, oh, there's 2 2's, it's fine because they both map to 4. If I had a 2, 6, then that would not be a function because the 2 maps to 2 different values. So a function is a relation, but a relation isn't always a function. You have to apply the rule that x does not repeat. So moving on, talking about the domain and range. Domain is all the possible x values. We also refer to them as the independent variable or the input. Range is all the possible y values, which is the dependent variable or the output. So here we say that y depends on x because whatever you input into a function, you get out the output or the possible y value. So here, looking at these diagrams here, if you notice, we've got P, Q, and R. Those are elements of our domain. So you're going to have a D colon open bracket P, Q, and R. That's your domain. Your range would be what those map to, which would be M and N. This is a function because X does not repeat. It's okay for Y to repeat. I can have Q and R both going to N. That's okay. I just can't have Q going to 2 things at once. So if you notice the next one, P, Q, and R all map to different elements in the range, so that is also a function. This is actually going to be a one-to-one function because every x maps to a certain y. There's no repeats on the x or the y, but we'll talk about one-to-one more in a few minutes. The next diagram, notice that Q maps to 2 different elements in your range. So here x repeats, so this is not a function. Also, one more example here for domain and range, just with a set of ordered pairs. Your domain here would be all your x values, so it would be 1, 2, 3, 4, and 5. And your range would be 2, 4, 6, 8, and 10. So if you're just asked to list the domain and range, that's the notation you would use. Notice here, x doesn't repeat, so that would be considered a function. Now let's look at functions on a graph. To show that it's a function on a graph, the same rule applies, is that x cannot repeat. So on a graph, it has to pass the vertical line test, which just means I could draw a vertical line anywhere on this graph, and as long as it only crosses one time, that means your x does not repeat. So anywhere I draw a line, it only passes through one point. So this would be a function. Now when we look at the next one, notice that this line goes through 2 points here and here. And if I draw a vertical line in other places, the same thing happens. But it really only has to fail one time. If it crosses more than one vertical line more than once, it's not a function. So here, because that vertical line is going through 2 places, that fails to be a function. And for the same reason here, if I draw the line through there, it repeats, and you could draw that vertical line anywhere on this and it would fail the test. So this is not a function either. So on a graph, you have to pass the vertical line test, which means x does not repeat to be a function. Now, the horizontal line test is a test for if you already have a function. So it's a function to start with. It already passes the vertical line test. The horizontal line test tests to see if it's a one-to-one function. So this is already a function, but one-to-one means that y can't repeat either. So every x corresponds to exactly one y. So graphically, if it passes the horizontal line test, it's going to be one-to-one. So notice here, our first graph is a function. It passes the vertical line test. It only crosses at one point anywhere. But if I draw a horizontal line, it goes through more than one coordinate. And again, if it just fails even one time, any horizontal line on that, it's not one-to-one. So this one is a function, but not a one-to-one function. This one, notice it is a function. It passes the vertical line test, but and also it'll pass the horizontal line test. So this one is a function, and it's also one-to-one. The next one, however, fails both tests. It doesn't pass the vertical line test or the horizontal line test. So this one is not a function, which if it's not a function, you can stop. You don't even care if it's one-to-one or not, because one-to-ones are already functions. So this is not a function, but it's also not one-to-one. Okay, let's look at function notation now. This is just how we write a function in terms of f of x. So when we have our y coordinate, we can write that as f of x, which when you read f of x, you say y is a function of x, or y depends on x, where x is your input and f of x, or y, is your output. So we're plugging something in for x into the equation and getting out your y, which is your f of x. So just remember that y is interchangeable with f of x. So whenever I say f of x, that's the same thing as saying your y coordinate. And also, when you write an equation, you can have y equals, or you could have f of x equals. Those are the same. So let's look at evaluating a function first graphically. So if I give you a graph of a function and I say evaluate f of 2, that means I want to know what y is when x equals 2. So I'm going to go over to my graph. I've got x equals 2 right here. I'm going to go up, and whatever my y coordinate is there is my answer. So here I've got the coordinate 2, 1. So f of 2 equals 1. So it's whatever y coordinate it is at that x value. Now on this next one, it's just the opposite. I'm solving for x when my y equals 4. So again, I'm going to go where y equals 4, which is anywhere here. So that's going to actually be either one of those 2 points. So here I'm going to have 2 answers. This coordinate is 3, 4. X comes first, then y. This is going to be negative 1, 4. So where y equals 4, I have x equals negative 1 or x equals 3. So there you're given the y value and it wants to know what x coordinate corresponds to that. So just be careful there. Sometimes they give you the x, sometimes they give you the y, and you're finding the other corresponding coordinate. Algebraically, works the same way. Here we're using a different notation, h of p, but that's the same as p is our input and h of p is our output. So here, if I want to know what h of 4 is, I'm going to plug 4 everywhere there's a p in my equation. So h of 4 equals 4 squared plus 2 times 4. So that's going to be 16 plus 8, which gives you an output of 24. So h of 4 equals 24. You can also, that would be a coordinate if we graph that of 4, 24. So I just want you to get familiar with the different notation. All of these refer back to coordinates by their input and their output. Okay, on this next example, I want you to keep in mind what we just did and just follow the notation. So the first one says f of 2. So let's write that down here. Excuse me. F of 2 means I'm going to plug in 2 everywhere I see an x in my equation. So I'm going to have 2 squared plus 3 times 2 minus 4, which gives me 4 plus 6 minus 4, which comes out to be just 6. So f of 2 equals 6. The next one is asking me to find f of a. Now, even though a isn't the number, isn't a number, I'm doing the same thing. Everywhere I see an x, I'm going to plug in a. So I've got a squared plus 3 times a minus 4. And that's all I can do there. There's nothing to simplify, so that is your answer. So on these, if they give you a variable to plug in, you're going to have an answer with variables in it. You're not always going to come out to a number answer. Looking at 3, this one's a little trickier. It says f of a plus h. But just think about what that's telling you to do. If this is telling me to plug in a plus h everywhere I see an x. So I'm going to have a plus h squared plus 3 times a plus h minus 4. Here I can do a little simplifying. Make sure for this a plus h squared, that means you're doing a plus h times a plus h. So you need to FOIL that. So that's going to give me, first is a squared, outside would be a times h, inside would be a times h, and last would be h squared. And then I can combine the two middle like terms to get a 2a times h. So when I FOIL that, I get a squared plus 2ah plus h squared. So that's a plus h squared, plus, now I need to distribute this 3, which gives me 3a plus 3h minus 4. Now none of that will combine, so that is your answer for f of a plus h. So a little bit more involved there, but just follow exactly the steps of what it's telling you to do by f of a plus h. You're just plugging whatever it is in for x. Now the last one I have here, I want you to just take it a step at a time. I've got f of a plus h minus f of a over h. So again, let's start with the first part, f of a plus h. Notice we just did that in number 3 and came out to this. So my f of a plus h is equal to, and I'm going to put a bracket around it just so we can keep it separated. So it's that whole string. That's my f of a plus h, so I've taken care of that. And then I've got minus, same thing here, f of a. Notice we did that up here. So I'm going to put in a squared plus 3a minus 4. So that takes care of the minus f of a. And then that is all over h. Now I can do a little simplifying. I'm going to go ahead and drop my brackets because there's nothing to distribute. On the first one. Now the second one, notice I've got a subtraction, so I need to distribute a negative into each thing, which is just going to change the sign of everything in the second set of brackets. So I've got negative a squared minus 3a plus 4, or minus a squared, sorry, same thing, over h. Now notice here, now I do have some like terms. I've got an a squared and a negative a squared. I've got a 3a and a negative 3a, and I have a negative 4 and a positive 4. So all of that will cancel out and leave me with 2ah plus h plus 3h, and then that's all over h. And we can go a little further because every term in the numerator in the top has an h. So I can pull out an h, which will leave me 2a. Oh, I'm sorry, I lost a squared there. This should be h squared. So when I pull an h out of there, that leaves me with just an h plus 3. And that's all over h. Now our h's will cancel and leave you with 2a plus h plus 3. Now that's a lot of algebra involved, so just be careful as you work your way down. Be careful of your signs. Notice I even made a mistake by leaving out the h squared. So just be very careful as you go through and work it out. Also, don't try to cancel and like the denominator here, don't try to cancel it with just one term. This h is dividing each term that it's under. So the only reason I could cancel it is because every term up here had an h that I could pull out in front. And then you can cancel it like I did. Don't try to just cancel it just with one thing. So that's just a little, be careful with your algebra and you'll get down to the correct answer instead of doing all that work and getting the wrong answer. Okay, the last thing we're going to look at in this section is the parent functions, which is your basic toolkit of functions for what we're going to build all our other graphs off of. So these are like the basic parents, and then we'll add stuff to it and transform it into different functions, which will be their little babies. So know these functions, know what they're called, know what the equation is, and know what the graph looks like. So this first one is a constant function, which is f of x equals c, where c is any constant. So here, this graph would be f of x equals 2. So if I drew a line down here at -4, that would be f of x equals -4. So your constant function is just going to be a horizontal line through the y value. Because remember, f of x is the same thing as y. Our next one is the identity function, which is also called the linear function, which is the equation f of x equals x, or y equals x. And that is just a graph that goes through the origin and has a slope of 1. So think of this as if you wrote it as y equals mx plus b, you have y equals a slope of 1, x plus b is your y-intercept is 0, which gives you y equals x. So that's a straight line through the origin with a slope of 1. The next one is the absolute value function, which is f of x equals the absolute value of x. Notice it makes a v. So think of this, if we take the linear function and make it the absolute value function, all of your, if I plug in a negative x here, which would, if it was the linear function, would look like this. But when I plug it into the absolute value bars, it takes all those negative values and turns them into positives. So it flips that part of the line up. So that's why it makes a V shape. The next one is our quadratic function. Sometimes you'll hear it called the squaring function. So if you hear the term squaring function, they're talking about a quadratic. And it is f of x equals x squared. So every value you plug in for x is getting squared to get the y. So 1 squared is 1, but 2 squared is 4. I didn't quite make 4. 2 squared is 4. So 3 squared would be up here at 9. 4 squared would be at 16. Also, it makes a U shape because -1, when I square it, is going to give me +1. -2, when you square it, is going to give you +4. So the negative values become positive when you square it. So that's why it makes that U-shaped. The next graph is the cubic function, which is f of x equals x cubed, which notice here, it's positive in the first coordinate, but negative in the third coordinate. And that's because when you cube something, it'll keep the same sign. So if I cube a positive number, I have it times itself 3 times, which will stay positive. Or if it's negative, it'll be a negative times a negative times a negative, which will give you a negative. The next one on this row is the f of x equals square root of x. Now, it's only in the first quadrant because we can't have a negative under the square root. So that restricts your domain so that it's all positive values of x. The next and last row is the cube root function. Looks like this. It is f of x equals the cubed root of x. We'll give you that graph. The reciprocal function is f of x equals 1 over x. And the reciprocal squared function is f of x equals 1 over x squared. Okay, we'll talk about these a little bit more in the next section, but that's what we're going to talk about. Just make sure you know these graphs, what they look like, what they're called, and the equation for them.